Yes, welcome students. Today we are going to start a new chapter, that is rational number. So first of all, let's see what is rational number. Rational number is what? It is a collection of integers, fraction and negative fractions. As we already learned before, that is regarding this integers, fraction and negative fractions. So you know it very well. So we can say that the rational number is a set of numbers which contains natural number, whole number, integers, as well as fractions with its negative and positive sign. Now the rational numbers are of two types. One is that is positive rational number, another one is a negative rational number. So how we can define positive rational number? So let's say your first point is your if both the numerator and the denominator of a number are positive or it may be negative, then the number is said to be a positive rational number. So we can say that a rational number is said to be positive if both the numerator and denominator are of same sign. May be positive, it may be or negative. For example, it is given that 3 upon 5, so 3 upon 5 contains both numerator and denominator positive, so it is said to be a positive rational number. Another example is minus 4 upon minus 7. So here the minus 4 and minus 7 both, that is numerator and denominator, are negative, so it is said to be a positive rational number. So you can write some examples. Now what is negative rational number? So it is written here, that is it is if the numerator and denominator may be or of opposite sign. For example, we can say that either numerator or denominator of a number is negative. So one must be a positive, another must be a negative. So then the rational number is called a negative rational number. For example, minus 3 upon 5, here the minus 3 is your negative and 5 is a positive. So it is said to be a negative rational number. So now how we can represent a rational number on number line. So rational number can also be represented on the number line in the same way as we can represent fractions and integers, as we already learned in previous classes. So let's take an example how we can represent 4 upon 5 on number line. So first of all we have to draw a number line and mark some equal points on it as shown in your figure. Now one of the point is marked as 0. One of the point is your 0. Now the another point, move on right side with a 1 upon 5, 2 upon 5, 3 upon 5, 4 upon 5. That depends on the denominator. If your denominator is 5, then you can mark 1 upon 5, 2 upon 5, and so on. Since we know that the 5 upon 5 is exactly equals to 1, so just to above it mark it 1. Now we can see that 4 upon 5 that is lies between 0 and 1. And same way we can move on the left side also, minus 1 upon 5, minus 2 upon 5, minus 3 upon 5, and so on. Now how we can represent the standard form of a rational number. So standard form of rational number is what? Let's define. A rational number is said to be in standard form, that is in the form of p by q, if both p and q are integers and there is no common divisor other than 1. Or we can say that a rational number which is in the form of p by q is said to be a standard form only if p and q must be a prime number and q is never equals to 0. So in standard form, denominator never be equals to 0. For example, the standard form of 48 upon minus 60 is a minus 4 upon 5. It is also said to be an irreducible form of rational number. We can't reduce further if a rational number, then it is said to be in standard form. Now some important facts related to a rational number. Every natural number is a rational number, but a rational number need not be a natural number. So we can represent any natural number just by putting a 1 as denominator. So it can be represented in the form of p by q, that is 4 is represented in the form of rational number by 4 upon 1. But 4 upon 5 is not a natural number. Now 0 is a rational number. It is either neither positive nor negative. So we can say that 0 is a rational number because it can be represented in the form of 0 upon 1, which is a form of a rational number. But it is neither positive nor negative. Another important point is your 0 is greater than every negative rational number, but it is less than every positive rational number as shown in example. Another point, that is a positive rational number is always a greater than a negative rational number, as we know that all positive numbers are always greater than the negative number. So in case of rational number also it is true. So every integer is a rational number, but a rational number need not be an integer. So any integer can be represented in the form of rational number just by putting a 1 in denominator, but every rational number need not be an integer. Now the next point is, your every fraction is a rational number, but a rational number need not be a fraction. So what is the difference between the fraction and rational number is what? Rational numbers may be positive, may be negative, but fractions are always positive. So we can say that every rational number is a not be a fraction, but every fraction is a rational number. Now the next last point, that is every rational number can be expressed in the form of terminating or non-terminating but repeating decimal. So every terminating decimal is said to be rational number. Every non-terminating and repeating decimal is said to be rational number. Now equivalent rational number, as we already learned in case of fraction how we can make a equivalent fraction. So in the same manner we can make a equivalent rational number also. So we can get equivalent rational number either by multiplying or by dividing the numerator and denominator of the given rational number by the same number, both in numerator and denominator. For example, it is given 48 upon minus 60 can be written as minus 24 upon 30, which is the equivalent form of 48 upon minus 60, that we get by just dividing 48 upon minus 60 by minus 2 in both numerator and denominator. Now second example, minus 1 upon 5 can also be expressed in the form of 2 upon 10, which is the equivalent form of minus 1 upon 5, and we can get this just by multiplying numerator and denominator by just 2. Now absolute value of rational number. So absolute value of rational number is the actual value of the rational number which is without a sign. So for example, a 4 upon minus 5 can also be written as 4 upon 5, which is the absolute value of that is 4 upon minus 5. Similarly, the 4 upon 5 can that is its absolute value will be 4 upon 5. Now irrational numbers. What are irrational numbers? Irrational numbers are non-terminating and non-recurring decimals, or we can say that it is a decimals which are non-terminating and non-repeating. They are said to be a rational number. Examples are there. Root 2 is not a rational number. Why? Because root 2 cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. And the second thing is that root 2 is not a terminating and non-repeating decimal, so it is an irrational number. Now overall conclusion is that there is a set of numbers which is said to be a real numbers which contain rational number and irrational number. Some examples are given to you. Rational numbers contains integers and whole numbers along with fractions, and whole number contains zero and natural numbers. So it is a short summary of this chapter topic. Now next topic will be continued.